Hello everyone, welcome to Physmatica. Let's take a look at this pre-calculus inequality problem. Before you take a look at the solution, see if you can solve it for yourself. So I'm going to solve it. I'm gonna first start finding the domain, which is the first step and the best step to start any type of problem. So let's take a look at this. We have 2x minus 1, which has to be non-negative because it is under a square root. So from here, we can simply say that x has to be bigger than 1 over 2. So this is our domain in this problem, and simply you could say that x plus a square root of 2x minus 1 also has to be non-negative, which is correct, but you can clearly see that this case is actually satisfying that as well, so we don't have to go through that. This is our domain. And now for the part B, we are going to start working on our equation, and the idea is that this inequality, right hand side is positive, left hand side is non-negative, so we are allowed to take both sides to the power of 2. So now I'm gonna just take both sides to the power of 2, and as you know, one of the square roots going to vanish, so I'm simply gonna have 2x minus 1 is going to be bigger than 9, and from here, if I write this better, I'm going to get 9 minus x. Okay, so now I'm going to work on this. This is what we're going to focus on right now. There are two cases here. We know that the left hand side is always a non-negative value, but right hand side can be positive, can be negative. We have to define those conditions. If I call it C1, what happens if x is bigger than or equal to 9? It's very simple if you take a look at it. If I say x is 10, so I'm gonna have minus 1 for the right hand side and a square root of 19 for the left hand side, which is valid. So by just saying that x is bigger than or equal to 9, we can clearly see that 9 minus x is actually going to be less than or equal to 0. And this is so satisfying that is completely easy. We don't have to do anything else. This actually satisfies the condition when our x is bigger than 9. So when our x is bigger than or equal to 9, this condition is completely valid and we don't have to do anything else. And this is actually our case 1 of the solution. Now let's take a look at the C2 part. What happens if our x is less than 9? In that case, if you take a look at this, if I put anything else here that is less than 9, right hand side is going to be always positive. So I'm going to have 9 minus x is going to be positive. So I can just completely include this inequality, 9 minus x. So in this condition, left hand side is non-negative, and right hand side is always positive when x is less than 9. So considering that, and if you take a look at what we did here, we can again simply just take both sides to the power of 2. Let's just do that. Let's take both sides to the power of 2. So I have a square root of 2x minus 1 to the power of 2 bigger than 9 minus x to the power of 2. And if I go to solve this, the square root's going to vanish with the power of 2, and I'm going to have 81 minus 18x plus x2. And now let's make everything better by taking everything from left hand side to the right hand side. So I'm going to have x2 minus 18x minus 2x, changes the sign, plus 81, and minus going to go to the right hand side, going to change the sign. All of this is less than 0 or negative, so x2 minus 20x plus 82 is going to be less than 0. So we have this, and this is now what we're going to focus on. Again, don't forget, we have this when our x is less than 9. So the idea here is that whatever the solution for this quadratic equation is, we also have to consider that idea that x has to be less than 9. So we put this aside for now, and now let's go and solve this quadratic equation. As you know, it's a very simple thing to do. So let's just go ahead and solve this quadratic equation. So I have minus b plus or minus the square root of b2 minus 4ac over 2a. So now let's do that. It's gonna be minus 20 plus or minus the square root of, so this to the power of 2 is going to be 400 minus 4. Our a is 1, our c is 82 over 2a. Again, our a is 1, so it's going to be 2. Now let's solve this square root. So 4 multiplied by 82 is going to be 328. So I'm gonna have 400 minus 328, which is going to be 72. And 72 is simply 3 multiplied by 36 actually multiplied by 2. So let's just solve it. We now have the x and it's simply solved. We're going to have 20 plus or minus, so it's going to be 2, it's going to be 6 square root of 2, sorry, it's going to be 6 square root of 2 over 2, and simply from here you could say that x equals, so we're going to have 10 plus or minus 3 square root of 2. And this is the answer for our quadratic equation. But again, we also had this, x has to be less than 9. Now here you need to be a bit smart how you take a look at this. If you take a look at this quadratic equation again, x2 minus 20x plus 82 less than 0, negative. Let's see what we can deduce from the graph of this. We don't have to really draw it, we just have to just understand what's going on. So if this is my x and y's, our a here is positive, so we can just simply say that it's going to look like that. And we have two roots, correct? We found two x's, two values for this, 10 plus or minus 3 square roots of 2, one here and one over here. So let's just simply just solve it, like try to draw it like this. What is important here is to take a look at this. We want this to be negative. So the idea is that where is our result negative? When x is actually bigger, less than 10 minus 3 square root of 2 and 10 plus 3 square root of 2. When it's minus, our result is actually, our solution is positive. And again, here is also positive. So this part is the only part that we can accept. So our x has to be between 10 minus 3 square root of 2 and 10 plus 3 square root of 2. But then again, we have this and this. We also have to consider this in this solution. So this is bigger than 9. This is almost 14, I believe. So this is bigger than 9. Doesn't matter whatever the number is, but this is smaller than this result, and we have to take both conditions into account here. So our x is going to be between 9 and 10 minus 3 square root of 2. So you can consider that. So let me see, actually, yeah, this is actually 14.2, and we have this as well. Yeah, we have this as well. So now let's solve this problem. We had case 1, which in case 1 we had x has to be bigger than 9. If you remember from here, our case 1 was that x has to be bigger than or equal to 9. And our case 2 is that x has to be less than 9 and between 10 minus 3 square root of 2. Now this is going to conclude our solution. If you take a look at this, in one way we're saying that x has to be bigger than or equal to 9, which is here as well, and also x has to be between 9 and 10 minus 3 square root of 2. So we can just simply say that our solution is whatever the number that is bigger than 10 minus 3 square root of 2, and this is the solution for this problem. And to make sure, actually, if you have a calculator, you can just go ahead and add some numbers that is actually bigger than that into this part and see if it's actually valid and is actually going to work. Now let's take a look at the second question. In this problem we want to find all the sets of solutions for this inequality, and at the first look it looks a bit complex, and especially if you go and multiply the factors together and expand them, it's just going to be very difficult to even understand what's going on. But you need to be very smart how to approach this problem. The idea here is that we just want to understand the signs, and this actually makes everything much more clear and much more easier. Instead of just going to expand the problem, let's first again take a look at the domain and see what we can get from the domain. So in here, if we take a look at the domain, it's very clearly we cannot have the denominator as 0, so x cannot be 0. In the case of the x plus 1, if we say that that's equals to 0, x is going to be minus 1, so x cannot be minus 1, cannot be 0. And for the case of the sine x minus 2, it's, as we know, sine x can only be between 1 and minus 1. So let's just remake this here. So I'm just going to add minus 1 to the all sides. So it's going to be minus 3 sine x minus 2, and 1 plus minus 2 is going to be minus 1. And from here we can simply see that this factor right here in the denominator is always negative, always, in all the cases. So that's actually quite simple now, much easier to work with this problem. Now let's take a look at the factors on the numerator. So I'm going to work on the numerator now. Let me just change the color here. We have, for the first factor, e to the power of x minus 1. If I equal this to 0, I'm going to get e to the power of x equal 1, and this only happens when x is equal to 0, which we cannot have because we already said that our domain here, let me just write the domain here as well, is all the values except minus 1 and 0. So we cannot have 0 here. But let's take a look at the signs. If x is positive and if x is negative, considering that we are taking a look at this factor here, e to the power of x minus 1. If x is positive, e to the power of x minus 1 is going to be positive, and if x is negative, e to the power of x minus 1 is going to be negative. So simply said, while looking at this, we can just say that what we're going to have as the sign for this factor. And we do this because we are multiplying this together. So we can simply just say that when it's going to be less than or equal to 0 because of all this multiplication. So now let's take a look at the 2x minus 3 in the numerator. So for the case of 2x minus 3, if we equal this to 0, let's find the root first. X is going to be 3 over 2, which is not part of the domain and not part of these minus 1 and 0. So we can clearly say that this is acceptable, and this is another critical point that we need to take a look at. And now let's take a look at the 2x minus 3 itself, and we can say that when x is bigger than 3 over 2 and when x is less than 3 over 2 here, the result for this factor is going to be positive, and for this is going to be negative. So now let's take a look at the other factor. The other factor is going to be x2 plus x plus 2, x2 plus x plus 2, which is again the simplest one. If you just find the delta for this is going to be minus 7. That means that we don't have any root, there is no roots, and that makes our life much easier. Again, in here, if we have an a here is is 1, which is a positive number, so we can just simply say that the parabola looks like this, and because there is no root, it never touches the x-axis, and from here we can also conclude that it's always positive. So at the moment, if you take a look at this, again, we have very simple ideas here. This is always negative, this factor, and this factor is always positive in any case. So now we have four factors that we have to find and think about when we are dealing with the ranges. So now we did that. Let's take a look at the denominator again, which we really don't have to, because we have x equals 0 from the denominator, and from here we can simply say that when x is bigger, when x is positive, this sign is positive, and x is negative, this sign is negative. And for the other factor, which is x plus 1, simply said, if x bigger than minus 1, this is going to be positive, and when x is less than minus 1, this is going to be negative. So that's it. And now we make something like a sign chart. Let's just do that, which is quite simple. But let's take a look at the ranges again. So we had our x to be bigger than, and let me just write it better here with this color. So we had our x from minus 1, that is less than minus 1. Then we had our x between minus 1 and 0. Then we had a range that our x was between 0 and 3/2. And in the end, we got that the other critical point was the case that we have our ranges of x being bigger than 3/2. Now let's take a look at this first case, when our x is less than minus 1. When that happens, what happens to this factor? E to the power of x minus 1. So this is clearly going to be minus. For this factor, x to the power of 2 plus x plus 2. Again, I'm looking at these factors right here. 2x minus 3, x2 plus 2, with this, which is always positive, that factor. So this doesn't matter what we add. This is always to be positive. Then we have 2x minus 3, which is going to be negative in this case. And for the denominator, if you take a look at it, we said that sine x minus 2 is always negative. For the x, when our x is less than minus 1, this is negative. And then for the x plus 1, this is also going to be negative. So if I now bring all of this together and take a look at the sign values, I'm going to have a negative value, another negative value, two negative values, and one positive here, and then 3 negative in the denominator. So this is going to be positive over negative, which is negative. And does this accepted in our inequality solutions? Yes, because again, take a look at this. In the problem itself, we said that it should be negative or equal to 0, which is correct. And in here we can say that this range, this limit, is part of our solution, and we can have x's that are less than minus 1. Now let's take a look at this one. I'm not gonna go completely through the solution because it's very simple. Now you can just see that we need to find regarding the signs. So if we just take a look at when our x is between minus 1 and 0, we are going to get that the first factor is going to be negative, second factor negative, third factor is always positive, this one is always negative, so this one is always positive, this one is always negative, positive, and simply this one is x, which is going to be negative. This is going to be positive over positive, which is positive, and we cannot have that because this is not in the sets of the solution that we want. Now let's take a look at the other range. I'm going to write it here. When our x is between 0 and 3/2, this is going to be negative, the first factor. Second factor, first factor is going to be positive, second factor is going to be negative, and the third factor is always positive, as we said, because there was no roots. Our sine x minus 2 is always going to be negative, and then in the denominator both factors are going to be positive, and from here we will have minus over minus, which is a positive, and this again is not in the solution that we want, so we cannot have this range as well. So these two range does not exist in the sets of solution. Now let's take a look at the last one, which is when our x is bigger than 3/2. And for this one, if we just calculate it, we can simply say that first factor positive, second factor positive, third factor always positive, first factor negative, always negative, and these two are also simply gonna be positive because this is just x. So from here we can just say that this is going to be negative, and this is part of the solution that we want. So we have this x bigger than 3/2 and x less than -1. These two are in the sets of solution that we are looking into. Now just simply let's do the last part, which is looking at the zeros. It's not very difficult. The only way that we need to take a look at the cases that are zeros. In the denominator we only have x plus 1 and x, which is we cannot use because these two are actually part of our roots, and we only have this as another critical point, which is also part of the sets of solutions that we have here. So we simply said all we have to do right now is to just add everything together, and we can simply see that our solution is going from -infinity to -1 here, union with 3/2 to the plus infinity. And the reason here that we can include 3/2 is that simply because we can actually have it as part of our solution when we look at the numerator, and we can simply see that it is part of our solution and part of the critical point that is also part of our domain. So that can be included, and this is the solution for this problem. It's a very simple problem, but actually this is part of the one of the Olympiad problems in the 80s in Russia. It's not very difficult, but if you go ahead and multiply these together and expand the inequality, then it's going to be very complex to solve. But the best way is actually this: you just look at the factors, especially because this is multiplication. So that's why we can do this, and you can simply solve it. I hope you liked it. Please don't forget to like and subscribe. Thank you for watching.